Okay, so subtracting rational expressions is just like adding them, except we have that minus sign. And sometimes that minus sign can cause us a lot of grief. And so when I do this example for you, I'm going to write everything necessary to do it, okay? I'm not going to do any shortcuts, because when you start doing shortcuts with the subtracting, sometimes you make some very major mistakes, okay? They start out minor, but it turns into a major mistake. Okay? All right, so first of all, what is my first step going to be in subtracting here? Okay, we're going to factor, all right? Factor the denominators if we can. All right, so I'm going to rewrite it. Okay. Brooke, how many different factors do I have in the denominator then? Two of them. Okay. So those two factors are going to be my denominator. So I want a little more fraction. Now, I have that common factor on the fraction on the left, so I'll just copy down that numerator. Okay. Now, since the one on the right is missing x minus 3, I've got to multiply the numerator and denominator by x minus 3. Now, what I'm going to do is I'm actually going to write that minus quantity x plus 5 times quantity x minus 3. Okay? I'm writing it because I don't want to forget anything. All right. Okay. Now I'm going to FOIL the x plus 5 and x minus 3. And I'm going to leave my minus sign there, and I'm going to put that answer in parentheses. So we get x squared. 5 minus 3 is 2x. And 5 times negative 3 is negative 15. Okay. Now, I left it in parentheses because I don't want to miss anything. Right. Now, I'm going to distribute the negative sign. So we have 2x squared minus 30 minus x squared minus 2x plus 15. Right. Continue to write it all out. Now, I'm not telling you have to, but for some of you, if you don't, okay, you will miss somewhere along here the correct sign, and which will cause you a major error in your answer in what was a minor mistake. Okay. I get tired of writing this. Okay. So now I simplify, and 2x squared minus x squared is x squared. Look for my x's. I just have a negative 2x. And negative 30 plus 15 is negative 15. Can I factor the numerator now? Okay. So the numerator is x minus 5 and x plus 3, right? So I can cancel the x plus 3's, and my result is x minus 5 over x minus 3. And x cannot equal plus or minus 3. Okay. And I know that I've probably, as far as all of you are concerned, probably done it more steps than what you will do. Okay. But I want you to be careful that you don't miss something, okay? You know, this minus sign, sometimes that thing ends up becoming a major point in our mistakes. Right? And so you want to make sure you don't make that major mistake, okay? All right? So just like adding, but you got to be very careful with that minus sign. Okay, what do you think? You guys can do that? Okay, all right, let's go ahead. Now, simplifying complex fractions. Now, they say this is a complex fraction. I totally disagree. I actually think this is very simple. Okay? You don't yet, but as soon as I tell you how to do it, you'll be like, really, that is pretty simple. The next one is example B here is not as, or part B is not as simple, but this actually is quite simple. Because this problem here is the same as number 12, or number 13, or number 14. Or it's the same as number 30, 29. Okay? What are these? They're dividing, right? And if you have a fraction divided by a fraction, what are you supposed to do? Okay? Multiply by the reciprocal, right? Okay? So that's exactly what I have, because if I think about this, that all this really is a big fraction bar, which means that I have a fraction divided by a fraction. And so all I need to do is take x plus 2 over x minus 1 and multiply it by x plus 5 over x minus 3. Okay. And this one's nice because there's nothing to simplify. All I'm going to do is write it as a product of those factors. All right. So that's not so complex, is it? Okay. It's actually something you've done lots of before. A fraction divided by a fraction. Now, part B here is a little more complex. A little bit. Can anybody tell me why this one is a little more complex? The plus sign makes a difference, because what's wrong then? I don't have just one fraction. So since I don't have just one fraction in the numerator, I need to make it so there is just one fraction in the numerator, which means I need to get what? Common denominator. In this one, though, that common denominator is going to be really easy, right? Because that common denominator is what? 2x. Okay? All right? Because I have x in the left side and 2 in the right side. They have nothing in common, so my common denominator is the product of them. So we have to multiply this by 2 over 2, right? And this one by x over x. So really, it's not so complex. It just has a little bit more work to it. So we get 6 plus x squared over 2x. I'm dividing by a fraction, right? So if I'm dividing by a fraction, I need to multiply by the reciprocal, so I can rewrite this as x over x minus 1. Okay. So are there any common factors that I can cancel here to simplify this? But Cynthia, there's x. Right. I have these two x's here that I can cancel because those are both factors. Because I'm multiplying. So we get 6 plus x squared, which I'd rather see x squared plus 6, over 2 times x minus 1. Okay? All right. Example, and this other example is, you don't like it. Okay, let's just put it that way. You plain and simply won't care for this because, 1, it's a word problem, and 2, it kind of gets tough sometimes. All right, these word problems do. But we're going to be dealing with fractions, which now you're like, hey, fractions are no big deal, are they? All right, so maybe you don't feel that way. A hiker averages 1.4 miles per hour when walking downhill on a mountain trail, and 0.8 miles per hour on the return trip when walking uphill. What is the hiker's average speed for the entire trip? Round to the nearest length. Okay. Now, here's what happens, is that we get confused because they started putting words in our problems. Okay? All right? Even though we've been working with letters like crazy, when you put those letters together and make words, I have issues with that. Okay? Now, what is this problem talking about? Okay. Average speed, what else? What other things? Walking, okay, all right. So when you walk somewhere, okay, so if I'm this hiker and I'm walking downhill, and to do that, if I walk at a certain speed, I also have to have something else that's affected when I do that. What's affected by my speed? Time is, okay? Time. And so if I'm going to go downhill on this mountain trail, that I have a certain speed that I go, and so that results in me having a certain amount of time that I walk, right? And if I go back uphill, okay, I have a certain speed, and since my speed is less, my time's going to be more, okay? So we have two situations here. We have, and when we're talking about time and speed, what do those things go together to make? Distance, okay? Time and speed is distance because, you know, if you're going to, now all of you guys are either driving or close to it, right? Okay? All right. So if you get in the car and you drive into Jackson, okay, and you go at a certain speed, it's going to take you a certain amount of time to get there, and when you multiply those two things together, I get my distance, right? Okay. So here we have our distance downhill is going to be equal to the rate downhill times the time downhill. And our distance uphill is equal to the rate uphill times the time uphill. That is a U. Crazy U's. I'll make good U's for you. Okay, hopefully those are better. Okay, all right. So, okay. The thing is they want average speed for the entire trip. Okay? Well, how far did they walk? We don't know, do we? But are these two distances the same? Okay? So they actually walked, their total distance was 2D, right? Okay. The distance downhill plus the distance uphill. Okay? All right? And since those two things are the same, I can say that's 2D. Okay? So their distance downhill, all right, so is equal to 1.4 times the time downhill, right? Correct? And their distance uphill was 0.8 times the time uphill. Now, we know these two distances are the same, correct? Okay, so do I need D and U anymore? If they're the same, then I can use either letter I want, right? So I'm going to get rid of the U's and the D's here. Distance is distance. All right, now, the big thing I need to know is how much time it took so I can figure out my average speed. So I can solve these two equations, right, for time. So the time downhill is equal to the distance divided by 1.4, and the time uphill is equal to the distance divided by 0.8. So my total distance, okay, this is the total distance, was 2D. What's my total time then? Because to be able to find my rate, my average speed, I need to know the total distance divided by the total time. Right? That makes sense? Okay. So what's my total time? How do I find my total time? Do what? Plug what in? We're not going to just plug it in. Okay. Colin, what'd you say? No, you can't just put anything in for D. Okay. That would be nice, but we can't just do that. Okay. What's our total time? Okay. What, Cynthia? Okay. My total time is the time downhill plus the time uphill, right? Okay. So if my total distance is 2D, my total time is the sum of these two things. Right? Because this is the time downhill and this is the time uphill. Okay. I told you this is a little tricky. So to find the average speed, I have to take my total distance and divide by my total time. So we have to do my total distance divided by, oops, and I started using little d, didn't I? What did I start using that for? Sorry. They should all be same d's. I like capital letters for those. And so we've got d over 1.4 plus d over 0.8. So we need to simplify this complex fraction. Okay. Problem was getting there, right? All right, so we need to get a common denominator. What's our common denominator going to be in the bottom? Okay, the product of them. What's the product of 1.4 and 0.8? Okay, so we get 2d divided by 0.8d plus 1.4d over what? Right? Because we're going to multiply this by 1.4 and this by 0.8. Okay. What's 1.4 times 0.8? What is it? 1.12. Okay. All right, so I'm dividing by a fraction, right? So I have to do what? Okay, so we get 2d times 1.12 over 2.2d. Hey, look at that. What's going to happen? It's going to be the same. What do you mean it's going to be the same? 2.2d over 2.2d. Not exactly. Close to that. Okay. I've got a d in the numerator and a d in the denominator, right? Okay, so the d's are going to cancel out, and all I have to do is do that simple multiplication with my calculator because I don't like decimals. Okay. So these d's cancel, and we get what? So 2 times 1.2 divided by 2.2 is what? Did you do all that and divide 2? Okay. 1.01? 2? 1.02?
Yes.
Okay. All right. 1.02, and that is our average speed. And that's 1.02 miles per hour. So doing these rate and time problems, okay, all right, they get a little tricky. All right. You have to think about, first of all, we're talking about distance equals rate times time. So you have to use all of that in your work that you're going to do. And you have to figure out, okay, am I adding things together? Okay, what things are being multiplied, and like that. So when you get to those problems, then you're going to want to, you're going to have some time here. Hopefully you'll be able to get to at least a couple of them you can work on, at least work on them with a partner to help you get there. All right.